Hi, today we are diving into the core of software architecture by exploring two critical concepts from Robert C.Martin's Clean Architecture: policy and level and business rules. These principles are fundamental to building systems that are flexible, maintainable, and durable. At its heart, any software program is a detailed description of policy. A policy is simply a set of rules for transforming inputs into outputs. These policies break down into smaller statements such as the core business rules, formatting requirements, and input validation. Understanding this hierarchy is the first step towards a clean design. The key to a stable architecture is separation based on change. Policies that change for the same reasons should be grouped together, following the single responsibility and common closure principles. Crucially, our dependencies must always point towards stability. This means our volatile, low-level components must depend on our stable, high-level components, forming a directed acyclic graph. To formalize this, we define level as the distance from the inputs and outputs of the system. The farther a policy is from input-outputs, the user interface, the database, the web, the higher its level. In a clean architecture, all source code dependencies must point in the direction of increasing level, protecting the core logic. This concept of level directly correlates with change frequency. High-level policies like core business logic change infrequently and for critical business reasons. Low-level policies such as database drivers or UI themes change frequently and for urgent but less important technical reasons. By separating these levels, we use a plug-in architecture to shield the important core from the trivial changes of the periphery. A classic example of this is the encryption program. The high-level encrypt class, which contains the core policy, depends only on abstract interfaces like char reader and char writer. The low-level I/O components like console reader implement these interfaces. This is dependency inversion in action, ensuring the core policy is completely decoupled from the volatile I/O details. Next, we focus on critical business rules. These are the rules that make or save the business money, and they would exist even if the system were executed manually. Think of a bank's interest calculation. These rules, along with the critical business data they operate on, are the family jewels of the system and must be protected above all else. These critical rules are encapsulated within entities. Entities are the highest level components in our architecture. They are pure business logic, completely independent of the UI, the database, and any specific framework. They represent the generalized business model that can be reused across any application context. Below the entities are use cases. These define the rules for the automated system operation. A use case is an interactor that controls the dance of the entities, specifying the steps for a particular application feature, such as create new loan. They are application specific, unlike the generalized entities. The dependency rule holds firm here. Use cases which are lower level must depend on entities which are higher level. The entities must never know about the use cases that call them. This inversion of control ensures that the core business logic remains the most stable and independent part of the system. To cross the boundary between the use cases and the interface adapters, we use simple data structures, the request and response models. These models contain no entity objects, no framework-specific types, and no UI details. They are the simple, clean pipes that maintain the independence of the business logic from the outside world. In conclusion, the message of these principles is clear. Business rules are the architectural foundation. Our goal is to keep this core pristine and independent. We achieve this by treating all other concerns, the UI, the database, the web framework, as mere plugins to the business rules. By following the principles of policy, level, and dependency inversion, we build software that is truly clean, robust, and enduring. Now let's quickly apply these principles to your architecture. First, what are the policy levels in your architecture? Next, what are the entities in your architecture? Third, what are the use cases of your architecture? Fourth, what are the business rules in your architecture? Finally, do you find overlapping between your policy levels, business rules, entities, and use cases? If so, how can you improve your architecture by applying the principles of single responsibility principle, dependency inversion principle, and common closure principle? If you like this content, please like, comment, share, and subscribe for similar content in the future. See you in another video. Until then, elevate.